Hi everyone, welcome to today's GCSE Higher Revision video. Today we're going to be looking at the equation of a line, so y equals mx plus c, and answering lots of different questions involving that. So in this video I'm going to go through some examples. I'll be giving you some questions to try yourself, so remember to press pause and try those questions. Just before we start, also if you have the Corbettmaths revision cards, the card on gradient, the card on the equation of a line, so our cards 47 and 48 will be useful for you as well. But in today's video we're going to be focusing on the equation of a line, so let's get started.
Hi, today we're going to be looking at linear graphs. We're going to start off with a couple of questions drawing linear graphs, and then we're going to be using their equations y equals mx plus c. So let's start off by drawing the graph y equals 2x plus 1. So if we're asked to draw the graph y equals 2x plus 1, there's a couple of ways we could do this. One way, and this is the way I like to do, is an xy table, and I choose do an xy table, and I choose some x coordinates such as 0, 1, 2, and 3. And to find the y coordinate, we're going to multiply the x coordinate by 2 and then add 1. So we're going to multiply all these numbers by 2 and then add 1. 3 multiplied by 2 is 6, plus 1 is 7. 2 multiplied by 2 is 4, plus 1 is 5. 1 multiplied by 2 is equal to 2, plus 1 is equal to 3. And 0 multiplied by 2 is 0, plus 1 is equal to 1. So we've got some coordinates that lay on this line, 3, 7, 2, 5, 1, 3, and 0, 1. So let's plot them. And that's the line y equals 2x plus 1. And that's it. And that's how you can draw a linear graph by using a little xy table. Now there's another approach, and whenever we look at the equation of a line, we'll look at the gradient being 2 and the y-intercept being 1, and know that we could start at the y-axis at 1, the y-intercept, and then use the gradient, go across 1, up 2, across 1, up 2, and so on. And then that would also help us draw the straight line graph. And we'll talk about that more whenever we look at the equation of the line y equals mx plus c. Okay, let's have a look at another graph now. So the next graph we've been asked to draw is the graph 2x plus y equals 4. So again, we could do an xy table. So we could do an xy table and choose some values for x, such as 0, 1, 2, 3, and so on. And let's find our values for y. So to find the values for y, we're going to substitute these values for x into our equation. So 2 times x, 2 times 0 is 0, plus y is equal to 4. Well, y would have to be 4, because 2 times 0 is 0, plus 4 is equal to 4. Next, if x is equal to 1, 2 times 1 is 2, plus y has to be equal to 4, so y is going to be equal to 2. If x is equal to 2, 2 times 2 is equal to 4, well then y would be 0. And finally, if x is equal to 3, then you've got 2 times 3, which is 6. Then you'd have to add negative 2 to get to 4, so y would be equal to negative 2. And there are some points on the line, 3, negative 2, 2, 0, 1, 2, and 0, 4. So let's plot them. And that's it. That's our line. 2x plus y equals 4. And that's it. Now in this question, what you could have done was actually rearrange it, make y the subject. And sometimes whenever you've got an equation of a straight line, it's quite useful to have it in the form y equals mx plus c. And I'll talk about that in a second. But if I had this graph, what I could do is make y the subject. So if I had 2x plus y equals 4. I could take away 2x from both sides of the equation. So on the left hand side, we would just be left with y. So y is the subject, so it's y equals. And then the right hand side, we've got 4 subtract 2x. So we could write 4 subtract 2x, like so. And that would be quite useful for our xy table, where we could do an xy table. And then we know the y value is 4 subtract 2 times the x value. And that would make the values in our xy table just a little bit easier. Alternatively, we could rearrange this and write y equals, and then put the minus 2x in front. So it's minus 2x plus 4. And then that would also be the equation of the line, and that's quite useful because we know that the y-intercept is 4 and it's got a gradient of negative 2, so across 1, down 2, across 1 unit, down 2, across 1 unit, down 2, and so on. And that's it. Okay, now before we have a look at the equation of a straight line, y equals mx plus c, I thought it might be quite useful to have a look at the gradient of the line. So the gradient of a line is how steep it is. So here we've got this line, and it's got a particular steepness, or gradient. And to work out the gradient of this line, we do the rise divided by the run. So to find the gradient of this line, you can choose any 2 points on the line. I'm going to choose this point here, the point 36. So the point 36 is one of the points I'm going to choose. And I'm going to choose this point here, 1, 2. I could have chosen the origin, 0, 0. I could have chosen 2, 4. I probably wouldn't choose this point here, 2 point something, 4 point something, because it's quite useful to have the coordinates where you know, for instance, 3, 6, you know the exact coordinates rather than guessing what the coordinate is. So we've got 2 points, 1, 2, and 3, 6. They're 2 points on the line. Now what we're going to do is we're going to make a little right angle triangle. So we're going to go across and we're going to go up. And we're going to do a little right angle triangle, and we've gone across. That's what we call the run, so how far we're going across. So we're going from 1 to 3. We're going from 1 to 3. So from 1 to 3, the run would be 2. We're going 2 units across, so 2. And in terms of the rise, well, we're going from a height of 2 up to a height of 6. Well, if we go from a height of 2 up to a height of 6, the rise would be 4. So we've got the rise divided by the run. So the gradient, now we call the gradient m. M is equal to the rise divided by the run. So if we have a look at our triangle, the rise is 4. And the run is 2, and 4 divided by 2 is equal to 2. And that means the gradient of this line is equal to 2. So for every 1 unit you go across, you go up 2. If you go across 1 unit, you go up 2. Across 1 unit, you go up 2. Now, I'm avoiding you saying 1 square across because it's not always 1 unit for each square, and you'll see that in our next example. So for every 1 unit you go across, you go up 2, and that's it. So the gradient of this line is equal to 2. Now, just to show you might actually see a different formula. The formula you might see is m equals y2 minus y1 over x2 minus x1. So you might have seen this formula, or especially if you're going on to A-level maths, you might see this one quite a bit. And it just means the same thing, rise divided by the run. So for instance, if you've got this coordinate here, we call it x1, y1, and this one we call x2, y2. So if we do y2 subtract y1, well, 6 take away 2 is equal to 4, the rise. And in terms of x2 minus x1, well, that's 3 take away 1, which is equal to 2, the run. So this is just rise divided by run. It's just another way of writing it. And that's it. Okay, so that's how you find the gradient of the line. Here's one for you to try now. Okay, so here's a line. Can you work out the gradient of this line? So press pause now and work out the gradient of this line. Okay, so if I wanted to find the gradient of this line, I'm going to choose 2 points on the line. I'm going to choose this point here, the point with coordinates 0, 50. And I'm going to choose this point up here, the point with coordinates 25, 250. So I've got 2 points on the line, and I'm going to make a little right angle triangle, like so. Okay, in terms of the run, how far we're going across? Well, we're going from 0 to 25. So we're going 25 across, so the run is 25. In terms of the rise, well, we're going from a height of 50 to a height of 250. So the rise is equal to 200. So that means the gradient of this line, m will be equal to the rise, which is 200, divided by the run, which is 25, and 200 divided by 25 is equal to 8. So the gradient of this line is 8. So for every 1 unit you go across, you go up 8. So if you go across 1, you go up 8. Across 1, go up 8. Across 1, go up 8, and so on. If you go across 5, you're going to go up 40. Across 5, you go up 40, and so on. And that's it. So that's the gradient of that line. If you got 8, well done. Okay, so we've had a look at how to draw linear graphs, and we've looked at the gradient of a line. Now let's look at the equation of a line. So the equation of a straight line is y equals mx plus c, where m is the gradient and c is the y-intercept. So c is where it crosses the y-axis, and m is the gradient of the line. So if we had this line here, this black line here drawn on this grid, in terms of its equation, well, if you work out the gradient, you do rise divided by run, then you get a gradient of 2 here. So it's y equals 2x because the gradient's equal to 2. And it crosses the y-axis at 1, so the y-intercept is 1, so it's going to be y equals 2x plus 1. So that's the equation of that line. And it's very important to know the equation of that line. So if you've got the Corbettmaths revision card, fantastic. Stick it up on the wall, bring it on the bus to school, learn it, get people to quiz you on it, and so on. Alternatively, if you've got window pen, remember to write it on your window, y equals mx plus c, and know what m is the gradient and c is the y-intercept. Okay, let's have a look at another question. So here we've got some information about a straight line. It's got a gradient of 8 and a y-intercept of 4. Write down its equation. So press pause and write down the equation of that line. Okay, so because the equation of a straight line is in the form y equals mx plus c, the gradient of the line is 8, so it's going to be y equals 8x, and it crosses the y-intercept of 4, so it's going to be plus 4. So the equation of that line would be y equals 8x plus 4, and if you got that, well done. Okay, let's have a look at another one. Okay, this time we've got a line drawn for us. Can you press pause and can you work out the equation of that straight line? Okay, so in terms of this line, it's got an equation y equals mx plus c. So we need to find its gradient and we need to find where it crosses the y-axis. So its y-intercept is quite straightforward. It's going to be 4, so it's going to be plus 4. But we need to find its gradient. So let's find its gradient. So I'm going to choose this point here, the point -1, 1. And I'm going to choose this point up here, the point 1, 7. And I could use another points. I could have used 0, 4, and so on. So I'm going to make a little right angle triangle. And in terms of the run, well, we're going from -1 to 1. So its run is 2. We're going 2 units across. And in terms of its rise, we're going from a height of 1 up to a height of 7. So the rise is equal to 6. So the gradient, m, is equal to rise divided by run, and that's equal to rise, which is 6, divided by the run, which is 2, and 6 divided by 2 is 3. So the gradient of this line is 3. And let's just check that. If we go across 1, we got 3, across 1, up 3, and so on. Y equals the gradient, which is 3, and then we've got x, and then we have then our y-intercept, which is 4, so plus 4, and that's it. So the equation of this line would be y equals 3x plus 4. Okay, let's have a look at another one. And if you got that, well done. Let's have a look at another one. Okay, let's have a look at the next one. So can you work out the equation of this line? So press pause and work out the equation of this line. Okay, so we want to find the equation of this line. So it's going to be in the form y equals mx plus c. So we need to find its gradient and we need to find the y-intercept. So in terms of its gradient, so it's gradient m. So let's choose 2 points on the line. So I'm going to choose this point, 0, 3. This point here, 0, 3. And I'm going to choose this point here, 2, 1. So I've chosen 2 points on the line. Now what I'm going to do is I'm going to make a little right angle triangle. So I'm going to go across. Now this time, because the line's going downwards, I'm then going to go down. I'm going to do my little right angle. In terms of the run, well, we're going from 0 across to 2. So the run's equal to 2. In terms of the rise, well, the line's going down, so its rise is going to be negative, and it's going down 2, so it's going to be negative 2. So the gradient is the rise, which is negative 2, divided by the run, which is 2, and negative 2 divided by 2 is equal to negative 1. So the gradient of this line is negative 1, and it's negative because it's going downwards. So we've got the gradient of the line, so it's y equals, now we're not going to write minus 1x, we're just going to write minus x, because we tend to write just minus x instead of minus 1x. Then, in terms of its y-intercept, it crosses the y-axis at 3, so it's then going to be plus 3. So the equation of that line is y equals minus x plus 3, and if you got that, well done. Okay, let's have a look at our next question. So this question says, a straight line with gradient 5 passes through the point 836. Find the equation of the line. So feel free to press pause and find the equation of this line. Okay, so if we wanted to find the equation of this line, we're going to write down y equals mx plus c, because that's the equation of a line, y equals mx plus c. And we know the gradient of the line's 5, so we can replace the m with 5, so y equals 5x plus c. Now, to find its equation, we're going to have to find the c, where it crosses the y-axis. There's a few different ways we could do this. One approach is to consider, well, if the line's got a gradient of 5, that means if we go backwards, we go across 1, down 5, across 1, down 5. And we could do that 8 times and figure out where it crosses the y-axis. Now, I think a much easier way is to have a look at the coordinates, which is 8, 36, and to label x and y. Remember, the first one's along the corridor, and the second numbers are up the stairs, so that's the x-coordinate and the y-coordinate. So for this particular coordinate, x is equal to 8, and y is equal to 36. If we substitute those values into our equation, y equals 5x plus c, we can find the value for c, and then we can then know the equation of the line. So let's do that. Okay, so y, well, y is 36, so we've got 36 equals 5x, so that's 5 times 8, which is 40, plus c. And then we want to find out what c is, so we're going to take away 40 from both sides of the equation, so take away 40 and take away 40. 36 take away 40 is equal to negative 4, and then the right hand side would just be c, so c is equal to minus 4. So that means the equation of this line would be y equals 5x minus 4, and that's it, that's the equation of the line. And if you got that, well done. Okay, let's have a look at another question. Okay, let's have a look at our next question. So our next question says, a straight line with gradient negative 2 passes through the point 7, 8. Find the equation of the line. So feel free to press pause and find the equation of this line. Okay, so we know it's going to be in the form y equals mx plus c, and we know the gradient's equal to negative 2, so it's going to be y equals negative 2x plus c. We want to find the value for c, so let's have a look at a point that it passes through. It passes through the point 7, 8. So that means that whenever x is equal to 7, y is equal to 8. So x is equal to 7, y is equal to 8. So we can substitute those values into the equation and find our c. So let's do that. So y, that's going to be 8, is equal to negative 2 times x, so that's negative 2 times 7, which is negative 14. Plus c. Now we want to find out what c is, so we then want to get rid of this minus 14, so we're going to add 14 to both sides. So if we add 14 to the left hand side, 8 plus 14 is 22, and on the right hand side we'd just be left with c, so c is equal to 22. So that means the equation of the line would be y equals negative 2x, and then instead of plus c it'd be plus 22, and that's it. And if you got that, well done. Okay, let's have a look at our next question. So this time we've been given 2 points, the coordinates are 2 points, negative 4, 3 and 8, 33, and we've been asked to find the equation of the straight line that passes through those points. So if you want to have a go at this question, feel free to press pause and to try this question now. Okay, so if I was to do a question like this, the first thing I would do is I would do a little sketch, and this is my little sketch where I've got a straight line, I've got negative 4, 3 and 8, 33. So that's a straight line and 2 points that it passes through, and that's just a little sketch that I've drawn. Now I want to find the equation of this line, so what I'm going to do is I need to find its gradient and I need to find where it crosses the y-axis. So let's find its gradient to begin with. So let's draw a little triangle, so let's go across and up, a little right angle triangle. So we're going from negative 4, so negative 4 to 8. So we're going 12 across. The run will be 12. We're going from negative 4 to 8. So we're going 12 across. Then in terms of the height, this one's going to height of 33. This one's going to height of 3. So we're going up 30. So the rise is 30. So we've got the rise and we've got the run. So the gradient m is equal to the rise divided by the run. So it's going to be equal to 30, the rise, divided by the run, which is 12. And if we do 30 divided by 12, we get, and that's equal to 5 over 2, or 2.5. So we've got the gradient of the line. So if we go back now, we know that our points, it passes through the points of negative 4, 3 and 8, 33. So we know that its gradient of the line is equal to 5 over 2 or 2.5, whichever version you want to use. So we've got y equals 5 over 2x plus c. So that's the equation of the line. Y equals 5 over 2x plus c. We've got the gradient, so we now just need to find the y-intercept. Now let's pick one of the points it passes through. I'm going to pick this one here because both of the coordinates are positive, and I just think that might hopefully be a bit easier whenever we substitute them in. So we're going to choose x and y. So y is equal to 33 and x is equal to 8. We're going to substitute those values in and hopefully find our c. So y is 33. So that's equal to 5 over 2 multiplied by x. That's 5 over 2 multiplied by 8, which is equal to 20. Or if you do 2.5 times 8, you get 20 as well. So that's equal to 20 plus c. And then if we take away 20 and take away 20, we get the 13. We get the 13 is equal to c. So c is equal to 13. So the equation of our line is y equals 5 over 2x plus 13. And that's it. Or if you wrote y equals 2.5x plus 13, that's right as well. And that's it. So well done. Okay, let's have a look at our next question. Now, sometimes you might be asked, whenever you're dealing with linear graphs or straight line graphs, where it crosses the x-axis or where it crosses the y-axis. Now, to find where it crosses the y-axis, we've looked at that before. That's the y-intercept. That's whenever the x-coordinate is 0. So if you want to find where a graph crosses the y-axis, you just let x equal 0. If you want to find where it crosses the x-axis, well, you know whenever it crosses the x-axis that the height's equal to 0, so you let y equal 0. So to find where it crosses the y-axis, you let x equal 0. And to find where it crosses the x-axis, you let y equal 0. So the question says, where does the line 5x plus 4y minus 12 equals 0 cross the x-axis? So if you had a little sketch of your x and y-axis, x-axis and y-axis, to find where it crosses the x-axis, you know the height is equal to 0, so you know y is equal to 0. So y is equal to 0. So let's substitute that into our equation. So we'd get 5x. And then we've got plus 4y. Well, 4 times 0 is 0, so that's going to be plus 0. And then we've got minus 12, so minus 12 equals 0. So because y is equal to 0, 4 times 0 is equal to 0. So we've just got 5x minus 12 equals 0. And now you can just solve this equation. So if we add 12 to both sides, add 12 and add 12, we get that 5x is equal to 12. And then if we divide by 5, and then you get x is equal to 12 over 5, or suppose 2.4. So that means the graph crosses the x-axis at 12 over 5, 0, or suppose 2.4, 0, whichever format you want to write it in, and that's it. So to find where a graph crosses the x-axis, you let y equal 0. To find where it crosses the y-axis, you let x equal 0. Okay, let's have a look at our next question. So next question says, find the gradient of the straight line with equation 8x plus 3y equals 30. So you want to find the gradient of this line. So if you want to have a go at this now, feel free to press pause and find the gradient of this line. Okay, so if we wanted to find the gradient of this line, what I would tend to do is I would tend to want to make y the subject to get it in the form y equals mx plus c. So let's make y the subject of this. So if we had 8x plus 3y equals 30, we want to make y the subject, so let's get rid of this 8x. So let's take away 8x from the left hand side, and let's take away 8x from the right hand side. So in terms of the left hand side, we took away the 8x to get rid of the 8x, so we're just going to be left with 3y. Now in terms of the right hand side, I could write 30 subtract 8x, and that would be fine. I tend to, because we want the form y equals mx plus c, I tend to put this in front, so it'd be minus 8x and then plus 30, just putting the minus 8x in front, and then the 30 afterwards, plus 30 afterwards. So I've got 3y equals minus 8x plus 30. I want to make y the subject, so I want to get rid of this 3, so I'm going to divide both sides of the equation by 3, so I'm going to divide everything by 3. So 3y divided by 3 would be equal to y. And in terms of the left hand side, we're dividing all of these by 3. So minus 8x divided by 3, that would be minus 8 thirds x. Just dividing 8 by 3 would be 8 thirds. So instead of being minus 8x, it'd be minus 8 thirds x. And then we have plus 30, we're dividing by 3, so it'd be plus 10. So that means that if we rearrange this, we get y equals minus 8 over 3x plus 10. Now we want to find its gradient, so the gradient of this line would be m would be equal to minus 8 thirds. And that's it. And if you're asked to find where it crossed the y-axis, it'll be the point 0, 10, or the y-intercept is 10. And that's it. So the gradient of this line is minus 8 thirds, and if we found it by just rearranging it, and if you got that, well done. Okay, let's look at our next question. Okay, let's have a look at our next question. So our next question says, work out the point of intersection of the lines y equals 2x plus 1 and y equals 4x minus 2. So we want to find where these straight lines cross each other. So feel free to press pause now and figure out where these straight lines cross each other. Okay, so if we wanted to figure out where these straight lines cross each other, well, we solve it like simultaneous equations. So we know y equals 2x plus 1, and we know y equals 4x minus 2. So that means that 2x plus 1 equals 4x minus 2. And it's quite nice that whenever you have straight lines, and if they're both in the form y equals and y equals, you can just put them equal to each other and then just solve that equation and then find out where they cross each other. Okay, so we now just need to solve this equation. So we've got 2x plus 1 equals 4x minus 2. Let's get rid of the lowest number of x's. So let's take away 2x and take away 2x. So we get 1 equals 2x minus 2. And then if we add 2 to both sides, so add 2 and add 2, we get 3 equals 2x. And then if we divide by 2 and divide by 2, we get x is equal to 1.5, or 3 over 2. So we've got that x is equal to 1.5. Now we just need to substitute that into one of our equations. And it doesn't actually matter which one you substitute it into, because you're going to get the same y value. So let's substitute into the first one. So we've got y equals 2x plus 1. Well, 2 times x is 1.5, 2 times 1.5 is 3, so we're going to get y equals 3 plus 1, and 3 plus 1 is 4, so y equals 4. So that means the point of intersection would be 1.5, 4, or I suppose you could write 3 over 2, 4, depending on which way you want to write it, and that's it. So the coordinates of the point of intersection of those two lines would be 1.5, 4, or 3 over 2, 4, and that's it. And what we done was, because it was y equals and y equals, we just put them equal to each other, solved the equation, and then just worked out the value for y, and that's it. Okay, let's have a look at our last question. So our last question, we've got the lines y equals x minus 7 and y equals 3x minus 19, and they intersect at the point A. And the point B has coordinates negative 2, 11. And we've been asked to find the equation of the line that passes through A and B. So feel free to press pause now to give this question a try yourself. So we want to find the equation of the line that passes through A and B. Let's find point A to begin with. So that's where these two straight lines intersect each other. So let's solve these equations. Let's put them equal to each other. So we've got x minus 7 equals 3x minus 19. Because we've got y equals and y equals, we can just substitute in this x minus 7 into here, because they're simultaneous equations, so we can solve it using substitution. Now if we solve this, let's then get rid of the lowest number of x's. That's going to be this x. So take away x and take away x. So on the left hand side we'll be left with negative 7. On the right hand side we'd have 2x minus 19. Then we want to add 19 and add 19. And minus 7 plus 19 would be 12. So that's 12 equals 2x. And dividing by 2 and dividing by 2, we get x equals 6. So x is equal to 6. We're then just going to substitute that into one of our equations. I'm going to choose the first one. We're going to have y equals 6 take away 7. And 6 take away 7 is equal to negative 1. So y equals minus 1. So y equals minus 1. So that means the point A has got coordinates 6, negative 1. Okay. Now we want to find the equation of the line that passes through A and B. So let's do a little sketch. So we've got negative 2, 11. So negative 2, 11 will be up here somewhere. Negative 2, 11. So negative 2, 11. That's the point B. And then we've got the point A, which is 6, negative 1. So 6, negative 1 will be down here somewhere. 6, negative 1. And that's the point A. And we want to find the equation of that line. So we want to find the equation of that line. So it's going to be y equals mx plus c. And we want to find m the gradient and c the y-intercept. So let's find the gradient to begin with. So to find the gradient this time, well, let's make our little triangle. So let's go across and down. There's our little triangle. In terms of the run, we're going from negative 2 to 6, so we're going 8 across, the run's 8. In terms of the rise, we're going from a height of 11 down to negative 1, so the rise would be negative 12. So the gradient of this line, m, would be equal to negative 12 divided by 8, and negative 12 divided by 8 would be equal to minus 3 over 2, or minus 1.5. So the gradient of this line passing through B and A would be negative 3 over 2, and you can tell it's got a negative gradient because it's going downwards. So we've now got y equals minus 3 over 2x plus c. Now we want to find where this graph crosses the y-axis, so we want to find the value for c. So what we want to do is we want to get one of the points and substitute it into the equation, minus 3 over 2x plus c, and find the value for c. So let's choose this one, 6, negative 1. So x is equal to 6, and y is equal to negative 1, and let's substitute those both into here. So y is negative 1 equals negative 3 over 2 times x. Well, it's going to be minus 1.5 times 6, and that's equal to minus 9 plus c. And then if we add 9 to both sides, that's going to give us 8 equals c. So c is equal to 8. So it means it crosses the y-axis at 8. So we were asking this question to find the equation of the line that passes through A and B. Well, that would be y equals minus 3 over 2x plus 8. And that's it. And if you got that, well done.
And that's it. So in this video, we're going through the equation of a line, y equals mx plus c, where m is the gradient and c is the y-intercept. And I've answered some questions on it. Over the next couple of days, we're going to look at parallel lines and perpendicular lines, and they're very important videos as well. I highly recommend, in preparation for those videos, you try the practice questions. So in the description below, there's a link to the practice questions. So the 64 days to go to your GCSE Maths exam. Keep up the hard work. You're doing really, really well. And I'll see you tomorrow for the next video. Cheers. Bye.